Cool. All right. I just want to show you guys. So we are going to be starting a new topic today. We're switching to an internal. Like I said, I need this so that way I have the data to send to external moderation. So we're just going to shift gears so I can get this kind of admin-y part of my job done. It's not a bad idea for us to switch to these gears because you guys have done ionic solids in this topic, so it's not a bad idea that we're picking up this internal. What else did I want to say? I think that's mainly it. It also gives you guys a chance just to play a little bit of catch up with the structure and bonding because I know you guys are a little bit all over the show. All right, so I have posted onto Google Classroom the qualitative analysis. I want to let you guys know that there's the key resources that have been posted. So if you go to the Google site, you're going to have the all the lessons for this topic, the resource sheet, the report template, and how you're going to write up your ions, and the checklist, and then all the lessons. So this is the first lesson that we're doing. These lessons are from my previous kind of teaching of it. It hasn't been updated yet, but you're welcome to look at it if you want to work ahead. I've given you guys a copy of the checklist online. I'll pass out a paper copy as well, but if you want to go through and tick off here, I'm happy for that. And the last thing that's on the key resources is a Google Doc for you guys to write your notes for this 2.2 ion identification. So if you're doing your notes online, I already made a Google Doc for you to write your notes in. It's helpful for me to see it so that way I can check it and I can give any feedback if I notice there's a mistake somewhere. Cool? All right, just making sure you guys know where everything is. All right, I'll leave this up. Internal SciPad, and I want you to do page 41, which is on the solutions and solubility. Really good way to recap some of the vocabulary that we're going to be using for this topic. Since it is a bit of a longer mahia, I'll give you a sticker for it, so call me over when it's done. And that's basically it. Make sure you write down today's date and the learning intention as well, and we'll get started in a couple minutes. Sound good? Cool. All right, let's get started. Most of you guys are done, so I'll move on. With that SciPad page, it was just a revision on the vocabulary for solutions and solubility. Just kind of a quick run through. Solute is the thing that you are mixing into it, generally a solid. And then the solvent is the liquid that you are mixing that item into. With the calcium, what is it, chloride question or something like that? Calcium chloride is like a solid ionic compound. That is my solute. And then the solvent is the water that I mix it into. Are we good with that? Yeah. All right. The way I try to remember it, because both of those words are very similar. Solute, I think you are saluting as you jump into the liquid. And solvent is venting for the solute to hurry up and jump in. It's a very stupid way to remember it, but it works. Are we good? Solute, solvent. Obviously then soluble and insoluble is talking about does it dissolve or does it not dissolve. That's going to be really important for this topic because we are going to be talking about precipitates, and precipitates are not soluble. The other nice thing about doing this kind of internal in the middle of our structure and bonding one is that it'll lead into the solubility rules, or not solubility rules, it'll lead into solubility, which is on that structure and bonding test. So it's quite useful for us to be talking about this as a concept. So today's learning intention, what we're going to be doing is defining qualitative analysis. It can get kind of confusing because there's two words that we're going to be talking about, and that's qualitative and quantitative. So qualitative, I'll talk about what that means, and then the second internal that we'll do with titration is a quantitative analysis. So just be mindful these internals sound very similar but are very different. Cool. And we'll also talk about the solubility rules today as well. So lesson plan today, to start introduction with the idea of qualitative analysis. I'm going to show you guys a clip of To Catch a Smuggler. It's kind of basically like, you know, Border Patrol, Australia or New Zealand, where they're trying to like check bags and see if there's drugs in there. Then we'll talk about what's in water and why would it be important to know what's inside the water. We'll also talk about the Māori of why, which is the life force of water, and think about why is it important for us to care about the health of my water and the life of that water. And then we'll talk about this assessment a little bit and how we identify what's going to be in the water in the context of this internal. And then we'll wrap up with some side pad on the solubility rules. Sound good? All right, cool. Let's talk then about the success criteria. I will pass this out. It's on a nice yellow piece of paper, so it's easy for you guys to kind of spot it in your sea of paper. So today we're going to be looking at ticking off 1, 2, and 3 from that checklist. What you'll also notice on that checklist is that I provided some information on the achievement requirements. The other thing that I've done is I provided the resource sheet that you'll get for this assessment. So with the resource sheet, you're going to get the solubility rules and the complex ion list. You'll also get this flow chart that's on the back. So I just want to start showing you guys what you are getting for this internal. Does that sound good? All right, by the end of today, you should be able to know what qualitative analysis is, define those 5 terms, which you did in the side path, and then lastly, you should be able to identify if an ionic compound will be soluble using those solubility rules. Are we good so far? Right, shall we catch a smuggler? Because I think that'd be funny. All right, here we go.
Welcome to Hartsville Jackson, Atlanta International Airport.
We're looking through the LOB, leftover bags that passengers left out there for whatever reason. When passengers leave bags, we gotta go through them, make sure there's nothing illegal.
Depending on the day, you can get about 30, 40 LOBs. They're the people that are in a hurry and they think they're gonna miss the flight and they'd rather leave the bag behind. Or the reason we check, the person might not want to get caught bringing something and leave the bag behind.
When I go through the bags, I try and be methodical. I try not to overlook anything. And coffee beans. Can't really see inside it. I'm gonna have to cut it open. Got a coffee smell, but we'll see what we got. Well, coffee is supposed to be brown, right? Coffee is not supposed to be white.
What do you think it is?
Okay.
Now we just cut open the rest and see. And again. Oh wow, okay. Try not to get too high or too low because you know you gotta test it. But when you start seeing the same thing, you're like, oh, okay. That's not the norm.
Who picked up odors? Somebody came around the corner. He was trying to did. Oh, yes, he did.
So this was inside the coffee. Gotcha. So do they look like commercially packaged?
Yeah, it look legit because see how it's stitched? Sometimes you just can't skip steps. It's that simple. It's that easy. That's glued on. So now we're going to test it and see what we have.
What do you think?
That's cocaine, man. I can smell it.
reading cocaine hydrochloride. So that's cocaine. It's just straight cocaine. No mixture, no nothing else. So, you know, it's a good day.
Nice catch.
3.51 kilos.
Wow, almost 8 pounds.
Yeah.
That's a lot.
Since I've been here, this is one of the largest ones we've had. And that's over a year and a half.
So I have a few follow-up questions that I want you guys to discuss in groups, and then we'll talk about it as a class. So first question that I want you guys to discuss is about what was the key question that these officers were asking when they found that white substance. And then the second question is, what ways did they go about confirming their hunches on what they thought it was? So take a moment and talk to each other, and then we will korero. All right, so first thing, what was the question they were asking when they found it? Was it cocaine? And also, what is this white substance? What did they do to confirm or that white substance was cocaine? There were multiple things they did. They did sniff it. I was very kind of uncomfortable with the fact they're using some like hunting knife to open things instead of like a box cutter. I feel like that was very dramatic. But they were saying things like what? Okay, they smelled it. What else did they do? They used the machine, and the machine was very accurate and said, yes, it is cocaine. What's the dog? That's the third one they were looking at. So there was lots of different ways that they thought it was cocaine, and they did lots of different kind of steps to make sure that they knew what they had. Huh? Do you want to be like, is it soluble? Let's put the cocaine into it. All right. So what I will now do is I'm going to swap to the document camera, and I'll give you guys the definition of what is qualitative analysis. Huh? The what? This one. Oh, the garlic. Yeah, I just thought it was funny. All right. So here's our first note that we are thinking about for our internal, and that's the word, what does qualitative mean? So qualitative analysis, does anyone want to take a stab at what that might be? Thinking about that. A quality analysis, that's a good way to kind of remember it. How good is the cocaine? How pure is it? No, not necessarily, but close, and that's going to be a good way to remember it. Qualitative analysis is basically how we ask what is there. So what is it is basically the question. And that was what they were asking when they saw that white powder substance. You're also going to hear the word, and I'll write it down so you guys can start thinking about it so you know the ideas. I need to look up the spelling. Quantitative analysis. Make sure I spell it right, because you know, guys, I'm The other term we think about is quantitative. Anybody want to take a stab at what they think quantitative means?
Large quantity.
Large quantity. So basically we're asking how much is there?
Yes.
So if we want to, because these words are very similar, if we want to help distinguish each word, I would think, what is the quality of the cocaine? To remember qualitative analysis. And quantitative, what is the quantity, the amount? So whenever we're doing science and we're trying to think about things, a lot of common questions we ask is what is it and how much there is. Say, for example, there's been a murder and we suspect that the person has been poisoned. So the, what's the word? Not the toxicologist, what's the person that does all the forensic stuff? Not the forensic scientist. There's a specific doctor that does the autopsy. So I can't remember the name of the doctor, but the person that carries out the autopsy is going to ask two questions when they think, someone's been murdered and they're trying to understand why. They will ask, okay, what was in their system? What drugs did they have in their system? What poisons did they have in their system? That's the first key. The next question then is, okay, how much was there? Was there enough for an overdose? Does that make sense? Yeah. So these are two very important questions that we're going to ask in science. This is going to be based off the first internal, which is the ion identification one. And then we're going to learn how to figure out how to quantify things with the titration internal. So two very important skill sets because you'll probably be using them if you do anything in science. When I was doing my master's degree, one of my mates, she was focused on the qualitative analysis for her question. She wanted to figure out how the drug was breaking down in someone's body and if those metabolites, how the drug broke down, was causing a toxic effect. I, on the other hand, was looking at quantitative analysis. I wanted to know how much something was there. So I hope that kind of helps as like a beginning introduction. Are we good? All right, the next thing that I have on our agenda is thinking about water and why would it be kind of important to know what's in a solution. So I'm going to put on my document camera here a flask of blue water, and I'm going to show it to you guys so you can see it. So I want us to kind of think about reasons why I would want to know what's inside this blue flask.
Because it's colored blue.
It's colored blue. We also see that we're in a chemistry lab, and it's in a flask, so it's probably some sort of chemical. Ideally, I have my chemicals labeled, but I don't in this case, which is not a good thing. Let's think about kind of health and environment. So if I stick my finger in here, why would I be maybe a little bit worried that my finger's sticking in this chemical? It could? Anybody? It could be harmful. It could be an irritant. It could hurt me. It could stain my skin. We don't really know. I'm just going to grab a tissue so I can dry my finger. So that's the first thing we're going to think about. Okay, I want to know what's in the water because it could be harmful. It could be an irritant. It could be an acid. I don't want that on my skin. It will hurt. Here's my other example of what we're thinking about. So I have a plant here. Zoom out a little bit. And I'm going to pour this blue liquid on the plant. Oh, you're like, what are you doing, miss? So why else would I want to know what's in the water?
Because you just pour it into the plant.
Because I just poured it into the plant. How does that tie into the environment? It could kill the plant. The plant could die because I don't know what this blue substance is. Yeah? And I also have to be kind of worried. Oh, that's leaking on the bottom. That's probably a little bit too much. So yeah, I want to think about those things because the water and the quality of that water could affect the life. Yeah? All right, there's one more thing I want to think about. So we've talked about it could be harmful.
Whoa. What is that?
So, what did I just do? I drank it, and what's the concern about me drinking it? I could die. I don't know what this is. I've just ingested it. It could have been a toxin, so that was probably not a very good idea. All right. So, I don't want you guys to worry. I thought it would be a fun little joke to see your reactions. This is not anything toxic. This is just blue Powerade. Yeah, it's just blue Powerade. But you were right to be a little bit worried because what else is blue?
Acid.
That copper sulfate. Yeah? So it could have very easily been copper sulfate that I just chugged for you guys. I did not. Don't worry. It was just Powerade. All right. Let me move this out of the way. I'm going to get some new paper to write on. So, one of the things we're going to ask asked in this standard is basically, okay, what ions are in my solution and how does it impact humans? How does it impact the environment? Yeah? So, what I want to kind of jump towards before we go into that is thinking about water. And water is really important. So, what are some things that water provides for us? Why do we need it?
Sustenance.
Substance. So we need to drink it. What else?
We are 70% water.
We're 70% water. What else? What else does the water provide
Feed
us?
our plants.
Fish, kai, food. Yeah? What else? We water the plants.
Energy.
And that also, again, provides us more kai and things like that. It also provides us safety. Because now we can. Does that kind of make sense? The water, group in the phones.
Like there's something energy was.
Energy, it's in that water cycle as well. And it's tied into the life, like very tied into how life is possible on this planet. We say that the reason why we can have life on Earth is because we have liquid water. That's a key kind of defining factor in planets in our galaxy or in our universe, is that they need to have liquid water to support life. And so it's really important that we take care of life and we recognize that water itself is its own kind of life force and being. And then it also supports the land as well. So it's really important that we take care of it and we restore that life force to it. So I have a couple of videos for us to watch just to kind of see what other people are doing to restore that mana to the water as well. So there's two different examples and I thought we could watch it just so you guys understand the importance of why we need to do this identification process and why we need to figure out quantities as well.
Right behind me is the Awa, the Kupurira River, and that's a river we're restoring to its original course and creating a series of wetlands. And we're creating lots of habitat, but also it creates recreation sites, places, trails we can bike on, open spaces we can fly kites on, and the local community are really using this valley already. Because it's massive. In the middle of Tauranga there's 364 hectares. In terms of the world, I can't find another 364 hectare wetland in the middle of a city. So it's pretty unique.
This project will see 200,000 native plants planted over the next 3 years. This will achieve the dual purpose of bank stabilisation and habitat enhancement in the area. The creation of wetlands in this area will help improve water quality. In addition, it will also provide habitat for native fish and also native wading birds. By working in partnership with Tauranga City Council, Ngāi Tamara Waho and Bay of Plenty Regional Council, the realignment of the river will assist in restoring the mauri and the life force of the area.
Cool. Does that make sense? So we can see that, like I said, that water is really important. Not only because we drink it and it can provide us food and things like that, but also it helps keep that environment nice and safe and stable, and with those wetlands as well, because it can help prevent flooding and things like that. So it's really important that we take care of these things.
Right behind me.
Here's another example. This one is with the Hut City, and again talking about restoring the Māori of the water.
Ka whai wāhi te iwi e mana whenua o te awa kairangi.
Where's the captions to it? Let's do that instead.
Ka whai wāhi te iwi e mana whenua o te awa kairangi a taranaki whānui I roto I te whakahoutanga o te pūnaha wai o te rohe. He whakahoutanga e hia miliona tāra nei te uara. I puta tēnei whakamārama I te kaunihera o te awa kairangi I te rānei. Hei tā rātou kua te huri ki te iwi I runga I te mōhio, he mea nui te mauri o te wai. Anei rā a iruere rerekura.
Ko te wai, e raumi waka ira, kei te tipu te whaitua Māori e kōrero ngā tai ana me te kauni ira.
The role of the whaitua here over the region of the whaitua is to bring the community's view of the water in the Awa, what quality do they want the water. So the investment that Hut City is making into the hidden resources that are there that look after our waterways is just huge. So that we're going to get clean quality drinking water.
We've had conversations so far and also through the whaitua process, so it's
incredibly important that we're engaging with them. But we're all on this absolute same boat that we want to make sure that here in Te Awa Kairangi, our awa is clean, our drinking water is clean, and that we're making sure that we're investing for future generations.
Ko te waka maeretanga mo te anamata te aronga nui, e waka ngā wari ai I ngā take a Uarangi.
We're turning our attention to how we can restore the Māori of the freshwater, and that is a intergenerational initiative, but we have to start now, and you know, in 30 years' time, we want to be in a position where it is much better than where we are today.
Engari tōna tikanga ka tōpū te tāua pūtea a te kauni ira.
We will need to invest over the next 10 years up to $300 million, which is doubling our current budget allocated. So that's a significant increase.
I ai ki ngā whika o ta tauranga Aotearoa, ko te awa Kairangi te wāi e no ongiana te nuinga o te taupuri Māori ki te upoko o te ika.
They all have a say. We've got 7 urban marae and the 2 iwi marae here. So they are good, and we have a great relationship with our council.
Mā te wai aora, ka noho aora, ngā apori. Iriwiri ririkura te karere.
All right. Just wanted to show you those 2 things, and the last thing I wanted to just show you are interested in kind of making sure we're caring for the environment and caring for water, and people are trying to move forward and be a little bit more mindful and not just kind of take resources from the earth, and about balancing and giving back and making sure things are sustainable, because there is a reciprocity relationship between us and the planet, and we need to be mindful of that. It gives a lot to us, so we need to make sure to take care of it as well. Are we good so far? All right. So, the last thing I wanted to talk about for today's lesson is how do we identify what's in the water? And this will also give me a bit of an opportunity to talk about the assessment and the standard in general. But basically what we're going to do is we're going to be asking questions and using a flow chart to help us figure out what is there. Are we good with that so far? All right. So let me grab my big copy of what you guys have. There we go. All right. So let me just fix that document camera for us. All right. Oh, not yet. So you will be given several things on this internal to help support you, so you don't have to worry about memorizing things. The first thing we will give you is we will give you the solubility rules, so you know then how to identify what is and is not the precipitate. The other thing we will give you is a list of complex ions. I'll talk about complex ions toward the end of the topic, so don't quite worry about that yet. So the way that we are going to figure out what ion is in that solution is by using a flow chart. You will be given this flow chart on the assessment, so you don't have to worry about memorizing it. And there are 2 flow charts that are there. One flow chart is used for identifying the anions. Do you guys remember what an anion is? Yeah. What is it? Yeah. The negative ions. So there are a list of negative ions that we will test you on. Those are the list. The first thing you guys will do is test it with litmus paper. Now, what does litmus paper do? It turns red or blue, so it's a pH indicator. So it helps me figure out acids and bases. So you will be able to then go, oh, does that litmus paper stay red or does it turn blue? And then you go down that pathway. And as you go down the pathway, you narrow down what you have until eventually you reach a dead end, and that tells you what your ion is. Are we good with that so far? Just want to show you as like an overview. So that's the one for the anions. We'll start with anions, and then we'll do cations as our second one. Cations are a little bit more difficult. It's a much larger kind of flow chart. And in this case, what you're going to be doing is taking some unknown solutions and dropping in something else to see does it precipitate. So precipitation is going to be really important for this assessment because we're using that as our identification tool to decide what pathway we go down. So, do you guys remember what the precipitate is? You did precipitate reactions last year.
It's like when you mix 2 things together and it's
Yeah, it's when we mix two solutions together and a solid now forms. And so there's going to be that exchanging of ions, and that new ionic compound could be insoluble and thus make a precipitate. So in some cases you will get precipitates, in some cases you won't, but as we go down these little flow charts, it will help us kind of get to a dead end point to figure out, okay, what is that ion there? And from that information, I'll be able to figure out what is inside my solution, and thus, you know, what problems could I have from that. Are we good so far with that? Cool. So I figured to show you guys an example. So we talked about this blue solution that I drank. So let's pour that into a beaker. It just was Powerade in the end, but you guys didn't know that. Also, it's April Fool's. I thought that'd be a really funny joke. All right. The other solution that I've put in is my copper sulfate. So you see when we're looking at them, they're both very similar, the blue solutions. So if I wasn't sure which one was the Powerade anymore and I took a chug, that'd be very concerning. So one of the ways I can identify that is by adding sodium hydroxide. So if we look at that sodium hydroxide, that's actually the first step to our cation test. And if I have copper, it's going to form a blue precipitate. So we can test that out. I'm going to add it into this solution here. And you guys did this last year. See how it's forming that blue precipitate? So that has copper in it. Now let's check my Powerade. Now I can't drink it. You see how there's no precipitate forming. So further confirming that I did not just drink copper sulfate earlier. Are we good so far? Does that make sense? All right, cool. So let's move on to the final activity for today. I had page 42, and I want you guys to work on those precipitation reactions and practice solubility rules. What else did I want to say? Basically, yeah, practice those solubility rules. Yes. Do you want to use the bathroom pass? Yeah, I have it. All right, when you get this iPad page done, let me know. I'll give you a sticker. Cool. We got about 2 minutes left, so I want to wrap up, and then we need to clean up. So today, what we focused on is defining what is qualitative analysis and the solubility rules.
Can you take this?
Yeah, you can hold on to it, or you can leave it with me. I'm happy either or. If you want, you can take the fat one home too. Yeah. Oh, do you not have a fat one at all?
Oh, no, I have a fat one.
Okay, yeah, you can hold on to that. For that success criteria, you should be able to define qualitative analysis, the terms, and also those solubility rules. All right, throw the spray, wipe down my desk. And that's everything.